Hello, it's Sam here. I'm doing the CPC port of Spectrum Analyser, and I thought I'd give you an update on where I'm at. So I've managed to add some more graphical features to the tool. So I've brought over the graphics viewer and the screen viewer from the Spectrum version. We've also got this palette feature as well, so you can store the current palette and then use it to display graphics. So the default view of this screen here is to show you the what graphics memory has been written to currently. So you can see the red means it's been currently written to. There's a good demonstration of that if we go down to this screen here underneath. So it's got this swinging rope, and it shows you how the graphics program has updated the characters on the screen to draw that, which is pretty cool. So let's go back to the main menu, because the palette is better here. I've already got that one stored. So what we can do is we can start looking through memory for graphics. So I know that there's most of the graphics are, well, most of the sprites are 16 pixels wide. So if we set that to 16 and then start scrolling through, we can see. So we can see here we've got some graphics here. We can zoom in if you need to. So if we set, what we can do is we can get that to the start, and then we can create graphics sets. So if I just do this, so that all these graphics here are 16 by 16. So what we can do is we can put in here something like 16 by 16 objects, and then if we do that, what that does is it creates a graphics set here, and then you can actually go through all the graphics to make sure that they're correctly formatted, and you can kind of do little animations as well, which is cool. So we could do the same for Jack as well. So if we move him up to the top, I know he's 16 by 24, so we'll set that to 24. I could maybe do all the 16 by 24 sprites, but I'll just do Jack for now. So let's put Jack 1624. So now we've got two graphic sets. We've got these guys, and when you select it, it will take you to the memory where it's stored, and you can see them all here. And Jack's here, and you can see when it goes green, it means that it's actually reading that graphic memory. So we can see that on this main menu here, it's animating Jack, which is using this frame. So what else we can do is we can click on any pixel on the screen, and it'll take you to the code that wrote that. And that's quite useful. So we can go into the game. Let's find a screen where I don't get killed straight away. Oh man. Oh, whatever. I'll just pick this one. Let's hope that guy doesn't get me. Can he get me there? Anyway, actually I can just pause it. It doesn't really matter. Right. So so what I can do is I can look at the background graphic here and just double click on that, and it takes me to this code here, which looks like a big unrolled loop writing to the screen. So if I follow it up, I can see there's this bit here which takes an offset and then adds it to HL. And if we go back, we can look at what happens here is we take A and we copy it into L, we load 0 into H. So then we end up with an offset that is, it looks like an index into a tile set. So what this is doing is it's times in the value by 16, and we know that each 8x8 character in the graphics memory will be 16 pixels. I mean 16 bytes, sorry. So what we could do is, because I've already looked at this code before, but so we can comment that, we can say A holds tile index or something like that. And then this is the base offset of tile set. So then we can actually go to that memory. Oh, actually, no, sorry. Well, the better way to do it is to view it in the graphics viewer. No, not that. I did have it right the first time. So yeah, view it in the graphics viewer there, and we know that these tiles will be 8x8. So here we can see we've got a load of tiles which look correct. So now we can create a tile set of those, or a graphics set, sorry. And I already know that there's 256 of these, because it's for one for every value of the byte. So, oh, have I just moved that there? I think I did, didn't I? There we go. So, tile set. So now we've got a tile set here. So what we can do with that is we can create a character set from it. So we know that this is mode 1. We can choose a palette. What's that palette there? It's quite a good one. I think, is that 0? Possibly. You can always change it later, but so that should create a character set. Yeah, there we go. So now we've got a character set, and we can view that in here. So we've got a tile set here, and if we wanted to, we could view it in a different palette. But I'll go with that one for now. So then we can go back to the code that was drawing to the screen. Now if we follow it all the way back up, I don't really know what all this does yet, but I know this draws the graphics for the entire screen. So if we keep going up, so we hit there's a function here. So what we can do is we can put a breakpoint there. So now if I go into a screen, you can see it hits this code here. And if I carry on, it only hits it once per screen. Just hit it there again. So we can kind of presume that this is the code to draw the entire background graphics. So we can call it something like draw background screen or whatever, or tiles, but whatever. So I've noticed here that there's this function which is just up here. It loads HL with this memory location, which looks kind of potentially important. So if I get rid of that breakpoint, so if we take a look at that memory, we can see it's been written to there a lot and read as well. So let's see what happens when we go into a new screen with that memory. So so we've got read and written to there. Again, it's the same. So we can. So the idea is that this is the character map. So what we can do is we can format that memory as character map. So the screen is 256 by 192, which is the same as Spectrum. So the amount of characters that would be is 32 across and then 20 down, because we've got 4 here that are not used for the actual screen area, for the play area. So if we put 32, 20, and we've got a character set or a tile set, which we set there, and add a label. So if we format that there, we can see the I don't know what these are, but we can remove those. Some labels that I've just got added. Well, maybe we shouldn't remove them, but I'll just do it to make it look nice. So there again, you can see the whole screen gets redrawn when Jack dies. But what that is that's holding the current character map for the screen. So if I move into a different screen, you can see it update there. If I go back to the main menu, you can see it's just using the same code. It's just a character map for that. I think they've even probably used it. Yeah, it's exactly the same size, play area. So yeah, somewhere in memory this all these screens will be stored. I haven't found those yet, but it probably won't be too hard. I did search the memory for the same bytes that are in this screen, but I didn't seem to be couldn't seem to find them. But yeah, that's kind of where I'm up to. There's this feature which has been added as well. Well, it's been brought over from the Spectrum version, and that's the event viewer. So we get an event gets logged every time the screen gets written to, or if palettes are changed, or screen mode is set, things like that, or the keyboard's read. So that's quite useful. But yeah, that's where I'm at. So yeah, thanks for watching. See you later.